So, what is RAG? Retrieval Augmented Generation. RAG blends two skills: finding the right information and writing a good answer. Put together, it helps AI answer questions with facts instead of guesses. What is RAG? First, the RAG retrieves. The system searches a knowledge source, documents, or databases, to pull out the most relevant snippets. Then, it generates. A language model then uses those snippets to craft a clear, natural reply. Third, the result, a tailored answer grounded in real information on demand. Why use RAG? It stays current, can pull the latest details from your content, precise, points to the exact passages that matter, and versatile, works across many domains. Typical uses: customer support pulls exact policy or how to steps from help docs. Healthcare surfaces guidance from clinical notes and references. Education fetches facts from textbooks, papers, or course materials. Now, before I proceed, let me explain why we need to use RAG in some cases with AI. As you know, ChatGPT is so powerful, but it doesn't have all the information in the world. Let's say you have a company, and inside that company, you have a guide, for example, or SOPs, or standard procedures that you need to teach new employees. That is private information. That is information that ChatGPT doesn't necessarily have access to. So, if you want to blend the power of AI with that guide, you need to use RAG. You need to build a database and equip AI with RAG capabilities to be able to ask the AI a question so that the AI can go and fetch inside that database, which is private information, to be able to give you an answer that is tailored to the question that you asked. This is one very simple example of how we use RAG in the world of building AI automations for businesses. This is why it's very important. Rather than the AI hallucinating, it allows the AI to actually fetch the right information to eventually help answer the question that the user is asking. How RAG works, step by step. First, RAG understands the question, figures out what the user is actually asking, then retrieves sources, search the document library for the most relevant chunks. Then it composes the answer. The model writes a response that uses those chunks as evidence. The same chunks it just retrieved, the model uses them as evidence to be able to answer the question that was initially asked. Simple example: what's the return policy for this product? RAG flow: the system finds the policy section in your docs and replies with the correct window, conditions, and steps without guessing. Why it matters: high accuracy, answers are backed by retrieved text, up to date info, pulls from your latest content, not just model training, broad coverage, handles many topics as long as the sources are available. Bottom line: RAG, search first, then answer. It makes AI more reliable, contextual, and useful, especially when you need responses based on your own documents or latest information. Now, you understood what RAG is, hopefully at least. Let's dive into what a vector database is. A vector database is a special kind of storage that saves information as vectors, vectors being long lists of numbers. These number lists capture meaning, so AI can work with things like text, pictures, or audio in a way that reflects their similarities. How does it work? Embeddings. An AI model turns each item, a sentence, an image, a sound, into a vector called an embedding. This is like a memory fingerprint the system can compare. So, we have a vector database. A vector database, for it to store information or data, it cannot store the language or text the way you and I read them. AI cannot understand that. For AI to understand that, it needs to break text into smaller pieces, we call those chunks, smaller chunks, then use an embedding model to turn those smaller chunks of texts into numbers. Why? Because AI can understand numbers and can give numbers meaning so that it can understand the meaning of texts. So once we embed those smaller chunks of texts, they now are turned into numbers inside the vector database, and those numbers have meaning. They are also coordinates. So those vectors, the long lists of numbers, have meanings that translate the meaning of the text into numbers. So they hold the meaning of the text. And now, once you ask the AI model a question that has an answer inside that vector database, what the model does is it goes and searches for meaning by searching for those numbers or vectors, or also called coordinates. You will definitely understand that as we move forward. It's a bit complex, but it's very easy to understand. So let's continue. Similar meanings means close coordinates. The magic happens here. Texts with similar meanings are mapped to coordinates that are close together in this space. I'm going to repeat. So let's say you have a paragraph. The AI model cannot understand the paragraph unless that paragraph is embedded. So the paragraph is turned into smaller chunks of texts. Then the embedding model turns those smaller chunks of texts into vectors, into numbers with meaning. Those vectors that hold the meaning of the text have coordinates. They are coordinates. And inside that vector database, the vectors have different coordinates. The words or the text pieces with similar meanings have similar coordinates, which means they are stored beside each other. Let me give you an example. Dog and puppy will be very close. Why? Because they have a very similar meaning, which means they should have similar coordinates, which means they should be stored beside each other on the vector database. However, dog and volcano will be very far apart because they have different meanings. Vector database benefits and applications. Prose handles many formats, works with words, images, audio, and more. Grows with you, can index millions and billions of items. Fast lookups quickly finds the closest matches among huge collections. And why it matters for AI, it acts like a long term memory for AI, enabling it to compare and understand complex information. Foundational for companies that want to add smart search, chat over documents, or personalized recommendations. When should you use a vector database? Unstructured content, documents, chat logs, pictures, or audio clips. Similarity search, show me items like this, articles, products, or songs. High dimensional features, when your data has many attributes learned by models. How is it organized? Each item is stored as a numeric vector. The database measures distance between vectors to find the most similar entries. Summary, a vector database is a smart index for AI. It stores meaning rich vectors so systems can recognize, compare, and retrieve related information across text, images, and audio quickly and at massive scale. If you feel like you still do not understand what vector databases mean or what RAG means, I urge you to repeat this exact video and listen to the examples I gave and listen to the simple explanation that I gave you as well. In the meantime, thank you for watching this video and see you on the next one.